Dear ladies and gentlemen, we'll have Mr. Bruce Eckel giving a presentation on making data classes work for you.
Okay, all right, sounds like it's working. So all of this is really examples, and all the examples are on the GitHub repo. So it's my repo, and look for data classes as types. Should be easy to find even if you forget it. And this started from, I do a podcast with my friend James Ward, and we interviewed somebody who had created they called it Smart Types library for Scala, and something just kind of clicked. I've been studying functional programming a lot in the last few years, and something just kind of came together, and I'm hoping that that happens for you during this presentation. So I'm going to start with, normally if your type doesn't, if your type is incorrect, you should throw an exception. But I want to show all of the errors, and so I created this little function that checks the expression, and it has a couple of error messages. The second one is usually out of range, that's why I separated it. Normally you would use an assert to check things and throw an exception, but I want to see all of the errors that happen in the example, so I wrote this. It's not terribly important, but you need to see what it was. And let's make this bigger. Okay, so suppose we have a very simple system where we want to do some kind of customer feedback. So we're going to have a thing called stars, and the value should be between 1 and 10. You know how customer feedback systems work. You can never actually give it 0 stars. So it'll be 1 to 10, and typical way we do this is just by using an int. And so an int is a type that has a value between minus very big number to plus very big number. And we want to make this, we want to adapt it to use for our stars so that it's between 1 and 10. And what this means, what we typically do, is we say, okay, every time I use this, if you're going to do it right, I need to check the argument to make sure that it's actually between 1 and 10, so my stars are correct. And so I do that there, and in this other function where I use, everywhere you use it, you need to check that it's correct. Now some of you might be looking at this going, oh, but you're returning stars plus 5, so what if you start out with stars that's 10, then you're going to return something that's 15. Well, we can only say that we're returning an int, because, well, that's all we have in this situation. So we don't really know that we're returning a stars object in this case. We're just returning an int. So maybe it's okay that stars plus 5 or stars times 5 is okay. Maybe that's fine. I don't know. But if we do want it to be a proper star, then we've got a problem there too. So this really isn't a very satisfying solution. Plus, anytime I add a new function, or if I were to change something about stars, I'd have to go back here and make sure that every place that I did a check, it would, I'd have to change it. So we got this stuff distributed all over the place. Let's see if we can look at this a little different. Oops, wrong way. What's the problem? How do we solve this problem traditionally? Well, now traditionally, this is one of the things that objects were supposed to solve for us. And the key was encapsulation. So the idea is that here in my constructor, first of all, in Python, by tradition, we say if it's preceded by an underscore, that means it's private. You can actually go in there and look at it, but and modify it if you want to, but that's what we call private. So we'll make it private, and then further down here, we're going to use the the property decorator to allow you to read it, but since there's no writer, then you can only read it. So pretty good. We've encapsulated it. We've hidden it inside of the class. And everywhere, each of the methods that I use, I need to perform, well, when I go into it, I need to perform some kind of precondition check, which is, in this case, the number of stars that you pass me, still an int. I'll check with my condition function to make sure that that's not too big. And then I'll perform some sort of internal operation, and then I'll do a post-condition check to make sure that I haven't messed anything up. And I need to do that every method that I have for my class. And the condition is simply using my check to, if you pass an argument, then it checks the argument. And if you don't pass in an argument, it checks self._number, the local number value. All right, well, this was the promise of object-oriented programming, that we would have this encapsulation and we keep everything safe. And at the time that I got started in it, which is when it was really starting to show up, seemed like a great idea. Seemed like a much better idea than what we had before with plain old functions. But this still looks pretty messy, and well, it doesn't seem great. Down here, I'm just showing that because I didn't have a setter, it prevents mutation, and you get an attribute error. And it's a lot of work. And if I were to add another method, I'd have to make sure, or if somebody else comes along and adds another method, they would have to know what to do to make sure that they did the proper precondition and postcondition checks. So it's not terribly satisfying. So let's look at another approach, which is data classes. So the idea of a data class is, and this is, I've actually lost track of when this was added to Python.
3.7.
Thank you. 3.7 was added in 3.7, and basically what you're able to do is define these class properties. So this is a property of the class, and then the data class, I want to call it decorator, but that's not the right thing. What are we? We do call them decorators, okay, because I know too many languages and I get the terminologies mixed up. So the data class decorator then takes this information and manufactures this class for you, which has a number of attributes, including it takes these properties, these class properties, and creates a constructor based on those that uses those in the order in which you define them, and you need the type annotations in order for it to know what to do with them. And so it creates a constructor that you can call. Don't have to give it the argument names, but you can. And each of the fields now has the same property in the object. So you can access name, number, depth, and then, I had a default argument here. So, and here's where I call the default, use the default argument. It creates a dunder EQ, so you can compare one of these messenger objects with another. There's a replace function that allows you to take an existing object and make a new object with one or more of the properties given different values. It's when you're looking at things in terms of functional programming, you get into this immutability idea, and the more you use it, the more you like it. So we'll look at that a little later. These are still by default mutable. So one of the things that means is that I can't use it as a key in a dictionary, and if I try to do that, it'll tell me it's unhashable. And the reason it's unhashable is because all of the properties are mutable, and it builds the hash key, the way that it indexes into the dictionary. It builds the hash key using all of those properties. And so if they're mutable, that means you could put the hash key in, you could modify the properties, and then when you're looking something up, it would generate a different hash key. And so you wouldn't be able to find the thing. So it just prevents it. And this is standard with any kind of hashing system across all languages. If it's mutable, that's kind of a bad idea. All right, so there is one more thing we'd like to add here, which is data classes have this option that allows you to say that the objects are frozen. And so what this means is that the constructor that it generates will make all of these properties immutable. Well, I mean, technically, you know, it's Python, you can always mush things around, but if you try to modify these things, you will get a frozen instance error. It will tell you that, oh, you can't do that because you said that this was supposed to be frozen. So now we've got something where, and this is much closer to what you do in functional programming, and we'll see the benefits of that in a second. And so one of the things that we see is that we're able to use the object as a key for our hash table, because if it's immutable, then it'll automatically create the dunder hash function. And so it's happy with that. So we can use it as a key in a dictionary, and here we look it up. All right, so in functional programming, well, one of the things that I was confused by for a long time is a phrase that I heard, I don't know, it was probably Luca Cardelli or somebody, one of the early type people, say that a class is not a type. And I didn't really know what that meant. But in functional programming, they talk about this a lot. And the phrase that you will sometimes hear is that a type is a set of values, and that is much easier for me to think about. It's just some way to define a finite set of values. And one of the things that you try and do, well, a couple of things you do in functional programming. One is that you make everything immutable so that you don't have to think about protecting that data. It's protected by default because you can't change it. And so it simplifies everything. You don't have to have this cluster of methods around your data to protect it. You say, here's my data, you can't change it, so you can read it, but you can't modify it. Everything's safe. The other thing that you want to do with types typically is to make impossible values unrepresentable. So in our case with the stars example, what we want to do is the impossible values are anything except for the values between 1 and 10. And so we'll start out by saying, all right, here's my stars class, and it's a data class, it's immutable. Here's the number of stars, and then the other thing that you get with data classes is this dunder post init function, because the data class takes your information and it generates the constructor for you. And so there would probably be some way to go and muck about with a constructor, but it's much easier to say, all right, automate the constructor, and then once it's done, I'll run this function post-init and I'll check the values. That's typically what you're doing with post-init. You might be able to do something else with it. But the intent of it was so you can check the results of this object that you've just constructed. And so here's the one place now where I do my check to make sure it's within the range 1 through 10. And now when I have my functions that operate on the stars objects. Notice they're no longer methods. I suppose they could be, but it's just a lot easier to think about them as standalone functions that accept stars objects and return stars objects. Now I don't have to worry about testing before or after I modify them or any of that stuff. That's all taken care of because the only kind of stars objects you can even create are the correct ones. So And also notice that here I actually am returning a stars object. And so it's clear when you read it that, oh yeah, whereas before I was returning an int, could be a star, could be a not. Here, it's very clear that I'm returning a stars object, and when I perform this operation here, if it goes out of range, the constructor well, the construction process, including the post-init, automatically discovers if I've done something wrong. And so what I want to point out here is how much simpler and clearer this is. Because here in the stars class, I define exactly what it is, and I can't create any of these objects that are incorrect. And so for the rest of the program, I don't even have to think about it. And that's kind of the aha moment that I want to initially get you to say, oh, I should do it this way. This is going to make my life much, much easier, and it's going to reduce all kinds of errors now. And if anybody uses my stars object later, if I decided to change the top number to 5 instead of 10, everything is going to be fine. Or at least if there are problems, they're going to be discovered immediately. I don't have to go through my code looking for all these tests. All right, so now let's look at the next thing that we try and do in functional programming, which is composing things together. So we have all these small pieces that work well, and then we want to be able to put them together. And what I'm going to compose here is a data class made from other data classes. So this will be, ultimately what we want to do is create a person, and the person is going to contain a full name, a date of birth, and an email address. So might as well make those into data classes as well. So the full name has some, so the post-init now is going to be checking the validity of the name after it's been initialized. And one of the tests I'm going to do is to make sure that there are 2 names. And so I split it, and if it's greater than, let's see, if it is, yeah, it should be greater than 1. And if it is not, if there's only 1 name, then it says, oh, you have to have 2 names. And you'd want to do all kinds of other things there. But you can do that all in this one place where you're talking about the name. And then once it's created, then you don't have to worry about it being used any other place. The second place is the birth date, and for the others of these, I'm just going to show some sort of checking is taking place. We'll actually look at birth date in a second. And then the email address does some sort of checking. And now we can compose a new data class from the existing data classes, and you'll note that the constructor that it creates requires you to pass the name and the birth date and the email address in, so it's very clear and readable what you get. And then, so if we go ahead and print that, you can see it performs the checking. As part of this person constructor, it calls the constructors for all of the individual parts, and then it displays, and this is one thing I didn't mention before, that the data class also generates a nice dunder stir for you, so that it produces, something you'd have to do yourself normally, creating a new class to make a readable string output. And so you can see this produces that for you as well. All right, so now I sort of waved my hands over the birth date, but that's kind of an interesting one to delve into a little bit more. And so let's look at, so the thing is, what we want to look at is the value of using these types. And data classes are really great, but enums are also a way to define a type, because with enums, you have a set of values. You have a finite set of values. It's defined at, well, call it compile time. I mean, it's there before, whereas the data classes we've seen are actually created at runtime, whereas enums are created at compile time. And one of the benefits of that is that your IDE can use that to do completion or whatever. If you've got an enum, and it can tell you, here are the options, and you can just select for them. And other more sophisticated things are possible. So let's look at the building a date. And So we're going to follow this pattern with frozen data classes. We've got a day, and it has the day number, and we're going to do a basic check, which obviously isn't thorough enough, but just for starters, we're going to say this day has got to be between 1 and 31. All right, and the year, we'll say, all right, this is somebody's birth date, so probably nobody's alive before 1900, and definitely no birth dates after 2022. So that'll be our post-init check. And now for the month, we'll use an enum. And so this allows me to have names for all the months. And again, can't remember when this feature was added, but you can assign each enum value to an object. And it might have even been 310. In this case, the object is just going to be a tuple. And the number is the month number that we traditionally use. And then over here we have the days of, how many days can be in that month. And so one of the things we can do is, we've got a static method here, and I can say, give me month number. And of course, it has to make sure that that month number is within range. And if it is, it goes ahead and produces the object associated with that number. And here is where we're solving the day of the month problem. So if I have a month and I have a day, I can pass the day into the month, and it says, okay, what's the number of that day? And then I'll index into the tuple for that month and make sure that it's less than or equal to that. So now we can guarantee that the days of the month are proper. And so now I can do this composition thing again, where I take the birth date, I've got the month, the day, the year, and those will do whatever checks they need to do as that is being created. And then in the post-init check, all I need to do is take the day and pass it into check day for my month. And it automatically checks to make sure that the day is within range. Okay, so that's pretty cool. And now I've got a set of these, and it'll go through and validate all of them. So my birth date apparently is okay. And then we've got a bunch of things that check and discover that, these things are out of range. Gives me all that information that they're all out of range. And so it's, I don't know, I was quite delighted to discover this. And also I did some tests, and because initially I think I just found somebody's example where they used a tuple, and I said, oh, you can use tuples. But then I did a test to find out that, oh yeah, you can assign it to any object at all, which of course, why wouldn't you be able to? It's Python. All right, so the month, so for the months, I used an, and the month can also be created using data classes, but it's a lot more complicated than just using an enum. And that's really the point of this example. And remember, all these examples are on the GitHub repository, so you can just look through them, and they're exactly what you're seeing here. And so I could do the same thing that I did before, and then I could actually use the data class, frozen data class for a month, and you can see it's significantly messier and harder to follow. So that's a good thing to know. Like when you have a finite number of elements, if you can put them in an enum, that'll probably be much better than using the data class approach. If you have a lot of elements, or you only need to create some of them, then the data class approach is going to probably be better. Yeah, so the point of this was just to show that it works, but that it's messier and less maintainable. All right, so I think, yep, that's everything. All right, so I did get through. We have 5 minutes left, but I guess we can't do questions. Is that correct? Yeah. We can do questions? We can do questions this time. All right. So I've got 5 minutes for questions. Are there any questions? Yes?
So you can freeze the class. Can you freeze, so you went through your examples of like make here, that's a new class, make whatever. Is there a way to freeze them without making a new class? Like
So is the question, can you take an existing class and freeze it?
no, can you freeze just 10 or just year without making a new subclass?
Oh,
Make a subclass underneath it.
can you freeze individual fields?
Without making the new class.
I didn't encounter that, so I can't really say. I mean, maybe, but I didn't encounter that. So I'm guessing probably not. Did some? Oh, we have an expert. No. Other questions?
Read-only properties.
You can. Oh, so you can individually make them read-only properties, like I did in the, the normal class example. But you do that by hand, yeah. Yes.
I think your example is not leap year safe. I think you can do the date. There's functionality. Date type to find out the number of days in a month to arrive the date. You have to do it by hand.
Okay.
Every 4 years you have 29 days in February, which you didn't account for, but it's there already. So
The observation was that I did not account for leap years, but there might be some clever way to do it. Yes. That's a good point. Yeah. Somebody else is going to notice that too. Anything else? Yes.
So for the person class, and then you give it like example like Thursday or something like that, does it actually check the time at all, or that's something we have to do like fits in?
Does it check the what?
Does it check that we actually give it a Thursday class? The person doesn't validate its own arguments. Doesn't runtime check the Thursday. Yeah.
Okay. You guys understood the question better than I did.
You can pass in anything you want for the name argument. It doesn't. The person doesn't validate it. The fact that you're passing in a first name or a name argument did the validation in the construction of that object, but person isn't validating its arguments.
Okay. Yeah, person is simply calling the constructors for the base types. For the composed types, I should say. Okay. All right. Okay. Oh, wait, no, we have one here.
Are you familiar with sydentic models? What is your point of view of them?
No, I'm not, but I mean, I've heard about them mostly just recently, so I didn't.
They're very familiar with data classes.
Yes.
Yeah.
Another thing is this attrs library that, yeah, so I should probably say attrs and pydantic. Yeah. So, yeah, I mean, there's a lot of work going on, but once you see the benefit of it, doing it this way, you can see why other people are working on making it better. All right, I think we're done.
Thank you very much for the
Yes.
great presentation.
Thank you.